All right, we're going to start looking at section 5.3. This is going to be fundamental theorem of calculus part 1. So we're going to go through and make some headway on this. So we're going to write down the theorem. This will be fundamental theorem of calculus part 1. So we're going to say assume f of x is continuous on a to b. A up to b. And we'll say if capital F of x is an antiderivative of little f of x on a to b, then we get the following thing happening. The integral, so the definite integral from a to b of little f of x dx is going to equal f of b minus f of a. Some notation stuff. So this is fundamental theorem of calculus, part 1. For notation, if we have capital F of x evaluated at a to b, this equals f of b minus f of a. So we'll be using this notation as kind of a middle step in a lot of these problems. So what we're going to do is just start going through some examples, seeing how to use this, and probably do this in a couple parts here. We'll just do the book examples today. So first example. It wants us to calculate the area under the graph. So it wants us to calculate the area under the graph of f of x equals x cubed over, it's going to be 2 up to 4. So the definite integral will tell us the area under the graph for this region. So we're going to basically calculate the integral from 2 up to 4 of x cubed dx. So by fundamental theorem of calculus part 1, I need to find the antiderivative of x cubed, which x cubed is going to go up to x to the 4th. If I left it that way when I took the derivative, when the 4 came down, there would be a 4 in front of the x cubed. We don't see that. So I need to put a 1/4 out front, so when the 4 comes down, it cancels with the 1/4 and leaves me just x cubed behind. We're going to evaluate that at the lower limit and the upper limit. So again, this is going to equal, this notation here equals, it's f of the upper limit minus f of the lower limit. And fundamental theorem of calculus part 1 says that all these things will equal. So we get 1/4. Evaluate the upper limit, so it's 4 to the 4th minus 1/4. Evaluate the lower limit, 2 to the 4th. And then we'll see what that ends up being. So if we do 1/4 times 4 to the 4th, that ends up being 64 minus 1/4, 2 to the power of 4. That's going to end up being 4. So 64 minus 4 is just 60, and that's our answer. So it's basically find the antiderivative and then evaluate it from lower limit to upper, or from the upper limit to lower limit. Substitute in the upper limit to get the first bit, subtract from it the antiderivative with the lower limit substituted in, and that will tell you the integral value. So we got a couple more of these. Example 2 wants us to find the area under the graph. So find area under graph. They give us g of x equals x to the negative 3/4 plus 3 x to the positive 5/3 over interval 1 to 3. So since we're asked to find the area under curves again, we're going to take the integral of our function g of x. We're going to go from 1 to 3 for the limits of our integration. 1's the lower limit, 3's the upper limit. We're evaluating x to the negative 3/4 plus 3x to the 5/3 dx. So I'm going to use the linearity of integration, and that's going to tell me I can treat this integral of this part here first by itself and kind of figure that out. Then I can put a plus, and then I can figure out the integral of this chunk over here. So if I add 1 is 4/4. So when I take the integral of negative 3/4, it's going to go up to negative 3/4 plus 4/4, which is 1/4. Now, when I take the derivative of x to the 1/4, the 1/4 comes down. 1/4 minus 1 is negative 3/4. So we have this mostly right, except the 1/4 comes down, and there's not supposed to be a 1/4 there. So I need to put a 4 in front of this, so when the 1/4 comes down, the 4 and the 1/4 cancel, so they go away, and you're only left with the x to the negative 3/4 part. Then I'm going to add to that. I have 3. The x to the 5/3, I need to add 1 to it. 1 is 3/3. 5/3 plus 3/3 is 8/3. So I'm going to leave a little bit of space because we're going to have the same deal that we had here where we had to put a number to kind of cancel the part that drops down. We're going to have to do that here. So I'm just going to scoot over a little bit and say, okay, this is x to the 8/3. When the 8/3 comes down, I only need a 3. The 3 needs to just be left behind. So when the 8/3 comes down, I need something to cancel the 8/3. So I'm going to put a 3/8 down there. So when the 8/3 comes down, it cancels with the 3/8. 8/3 minus 1 is 8/3 minus 3/3 is x to the 5/3. So the 8/3 and the 3/8 cancel. The 3 is left behind, and the x to the 5/3 is left behind. So this is the antiderivative of that. And so we're going to evaluate that from 1 up to 3. I'm going to algebraically simplify this part out just a little bit. Make it look slightly nicer. 3 times 3/8 is 9/8 x to the 8/3 evaluated from 1 up to 3. So then what we're going to do to evaluate this, we're going to say, all right, this is going to equal, it's the upper limit 3 plugged in for the x's here. Minus this expression with 1 plugged in for its lower limits. And then we're going to type that in the calculator. I guess you could figure it out in your head if you wanted to, but, or, you know, pencil and paper. I guess it's probably hard to do some of that in your head. But I'm going to use a calculator to speed stuff up a little bit here. On the AP test, they usually have the numbers work out to be not terrible. So, okay, that's a decimal. I'm just going to do this whole subtraction all at once. So it's going to be this. This is about equal to 26.325. And then if we put the other one in, that's about equal to 5.125. So if I put the whole thing together and get that, so if I put the whole thing together, basically I end up with, let's see here, what do we got? 4 times the 1 to the power of 1/4 plus 9/8 times 1 to the power of 8/3. I end up getting about, yeah, I've typed something in wrong. Oops, there it is. Okay, so I get, this is about equal. I'm going to round it to 3 decimal places. We get 21.200. It's actually 21.200144476, but rounded to 3 decimal places, we get that for our answer. So basically, this is a little, you know, you could do this, it'd be kind of tricky to do by hand, but use a calculator to kind of speed it up. Again, on the AP test, we don't want to round to these intermediate steps here. If you round to 3 decimal places here and round to 3 decimal places here, your answer may be off by too wide of a margin to count for the AP test. So for the AP test, if you're going to take that, you want to take this entire thing. So you want to type the whole thing in at once, or you want to use the store keys and you want to store this chunk here, like store it maybe as the capital A in the calculator. That chunk there, maybe store it as capital B. And then at the very end, reduce stuff down. So I typed it in all at once, then hit enter, and then rounded to 3 decimal places. But on the AP test, if you round in an intermediate step, then your answer may be off by too much to count and get credit for it. So you do want to be careful about that. Make sure you're getting holding off on rounding, so you're keeping all the decimals until the very, very end. All right, let's look at one more, and then we'll kind of pause on this, and we'll get the rest of them in a separate video. So, for example 3 here, this will be the last one on this part. We want to calculate. They're telling us calculate negative pi over 4 up to positive pi over 4 of secant squared of x dx. And then we want to sketch the region. Okay, so the sketch of secant squared, if we look at, let's say, from negative pi over 2, or not, let's just say negative pi over 2 up to positive pi over 2. Here's 0. We would have pi over 4 and negative pi over 4. Here, let me pull up Desmos real quick to show you. The sketch of this thing is going to be a, let's see here, Desmos. It's just going to be kind of a graph. Let's see, does this thing have secant? Desmos have secant in it. May have to do, okay, there's secant. So we want to graph secant squared. It's gonna look like a bunch of kind of teeth-shaped things that are on the top. So when we square it, they all stay up there. So we get kind of a bunch of this repeating kind of shape there. These bars here were the asymptotes, so it should fall, I think it's every pi over 2, I believe. Let me think. Yeah, that should be right. So what we got is we have, let's see here, what are we going to do? We got our graph there. What are we trying to do with this? We're trying to sketch the graph. So I guess in mine, since I don't have it quite as much height to work with, it's going to be kind of a lower thing there. And what we're finding is the area from here to here. So what our integral is actually calculating is the area from there to there on the graph. Okay, so we need to figure out what's the antiderivative of secant squared. If we remember from earlier, we got d dx of tangent of x is secant squared. So tangent is a function when you take its derivative as secant squared. Therefore, the integral from negative pi over 4 up to positive pi over 4 of secant squared of x dx, that will equal tangent of x evaluated from negative pi over 4 up to positive pi over 4. So what we need to do now is we need to calculate, we need to say what is tangent of pi over 4, and we need to subtract from it what's tangent of negative pi over 4. Tangent of pi over 4, if you remember, tangent of x is sine of x over cosine of x. So if you're at pi over 4 is on the unit circle, pi over 4 is here, it's the 45-degree angle. Sine will have, the x-coordinate will be cosine, that's square root of 2 over 2. The y-coordinate will be sine, which is square root of 2 over 2. Since they're the same thing at pi over 4, when you want tangent of them, it's square root of 2 over 2 divided by itself, so that's going to equal 1. And then we'll subtract from it. We want tangent of negative pi over 4. Negative pi over 4 is what happens when you go pi over 4 down this direction. The x value is still positive square root of 2 over 2, but the y value will be negative square root of 2 over 2. So sine is the y value divided by cosine, the x value. You would get negative square root of 2 over 2 over positive square root of 2 over 2. So tangent of negative pi over 4 is negative 1. So basically we're saying this is positive 1. That will become negative 1. We get 1 minus a negative 1 is 1 plus 1, which is going to ultimately equal 2. And we'll stop on part 1 here of section 5.3. We'll pick the rest of it up in a little bit and get that posted soon.